Welcome to Decoding the Universe, a deep exploration of the extraordinary life, groundbreaking science, and lasting legacy of Gerhard Herzberg. Celebrated as the father of modern molecular spectroscopy, Herzberg's journey is one of immense resilience and brilliant discovery. He was forced to flee Nazi Germany as a refugee, bringing his visionary talents to Canada, where he ultimately earned the Nobel Prize in Chemistry. Through his pioneering work, he unlocked the fundamental languages of molecules, providing humanity with the precise tools to decipher the chemical signatures of our cosmos. Join us as we explore the story of a man who delved into the heart of matter to help us understand the very fabric of our universe. To truly understand the men behind the science, we must examine the man in focus through his four core identities. First, there is the survivor. He fled Nazi Germany in 1935 with just $2.50 and a few optical plates, eventually finding refuge in the Canadian prairies. Next, we have the pioneer, the brilliant mind who mapped the elusive geometries of free radicals, unlocking mechanisms ranging from combustion to comets. Third is the laureate, honored with the Nobel Prize in Chemistry in 1971 for defining the electronic structures of molecules. Finally, there is the advocate, a fierce defender of pure science who fought tirelessly for the freedom of scientific inquiry against bureaucratic control. Together, these pillars define his remarkable legacy. Every great scientific journey begins with a spark, often forged in hardship. Born in Hamburg in 1904, young Gerhard Herzberg faced his father's early death and the crushing burden of post-World War I hyperinflation. His education was supported by his mother, who emigrated to the U.S. as a housekeeper to send back remittances, as well as by a private scholarship from industrialist Hugo Stinnes, which enabled him to complete his doctorate at TU Darmstadt in 1928. Although Herzberg's first love was astronomy, it required private wealth that he simply did not possess. Instead, inspired by his high school teacher's lessons on Bohr's atomic theory, he shifted his focus to the more accessible wonders of physics, a decision shaped by poverty, but one that was destined to change science forever. Between 1933 and 1935, dark shadows loomed over Germany. The catalyst for Herzberg's exile came when Nazi laws revoked his teaching license solely because his wife and scientific partner, Dr. Luise Oettinger, was Jewish. Desperate for escape, a lifeline emerged across the Atlantic. Former colleague John Spinks and University of Saskatchewan President Walter Murray secured a Carnegie Fellowship to rescue the brilliant physicist. Arriving in Saskatoon with nothing but personal belongings, $2.50 in cash, and a few infrared optical plates, the Herzbergs faced the daunting challenge of rebuilding their lives. Against all odds in the remote Canadian prairies, they constructed a world-class spectrograph from scratch, transforming a sanctuary of exile into a beacon of scientific triumph. To appreciate Herzberg's brilliance, we need to understand how he revealed the invisible using molecular spectroscopy in three elegant steps. First, the flash. Molecules absorb light energy, or quanta, within the ultraviolet and infrared regions. Next, the signature. Because light energy is quantized, this absorption creates distinct dark lines when the light is passed through a prism. This pattern acts as a unique cosmic barcode for each molecule. Finally, the translation. By employing quantum mechanics and the foundational equation delta E equals h over nu, Herzberg was able to translate these barcodes into precise physical measurements. Through this innovative technique, he mathematically mapped the size, shape, bond lengths, and angles of entirely invisible molecules, revolutionizing our understanding of the fundamental building blocks of matter. Capturing the invisible requires racing against time itself. The challenge lies in free radicals, highly unstable, short-lived molecular fragments produced during chemical reactions that vanish in millionths of a second, acting like ghost molecules. To trap them, Herzberg pioneered an innovative technique called flash photolysis. By unleashing intense, ultra-fast bursts of light to break apart parent molecules, he generated high concentrations of these elusive radicals and captured their unique spectra just before they decayed. The impact was monumental. Herzberg provided the definitive empirical proof needed to unlock the mysteries of how chemical reactions proceed, forever capturing the fleeting intermediates that theorists had previously only imagined. Let's explore the structural blueprints of nature through Herzberg's four defining molecular discoveries. First, the methyl radical, CH3, mapped with a planar D3 symmetry and a CH bond length of 1.079 angstroms, settles foundational debates on organic chemistry hybridization. Second, the methylene radical, CH2, revealing a bent triplet geometry at approximately 102 degrees, validating modern carbene reactivity models. Third, triatomic hydrogen, H3. Captured in an equilateral triangle with a Rydberg state of roughly 0.87 angstroms, provides the first empirical evidence of neutral triatomic hydrogen. Finally, the oxygen, O2, Herzberg bands. Revealing a linear geometry through forbidden UV electronic transitions, this crucial discovery explains the mechanisms governing ozone production right above us in Earth's atmosphere. In this remarkable achievement, scientists successfully mapped the cosmos without ever leaving the laboratory. By connecting the micro world of laboratory research with the macro expanse of deep space, Herzberg achieved a significant scientific breakthrough. The cosmic barcodes of transient molecules, such as CH+ and H2O+, were first isolated in a laboratory in Ottawa. With these precise spectral signatures, astronomers can now quickly identify the same barcodes in cometary tails and interstellar clouds, even millions of light-years away. The key takeaway from this work is that spectroscopy has definitively shown that the fundamental laws of chemistry are not merely local phenomena, they are consistent throughout the vast reaches of the universe. True giants in the field of science leave behind a definitive legacy for future generations. Between 1939 and 1979, Herzberg authored a renowned work known globally as the Spectroscopist's Bible. Through these significant contributions, he standardized the language of physical chemistry, effectively bridging the gap between theoretical quantum mechanical calculations and empirical laboratory observations. This monumental four-volume set encompasses decades of discovery. Volume 1, published in 1939, focuses on the spectra of diatomic molecules. Volume 2, released in 1945, covers the infrared and Raman spectra of polyatomic molecules. Volume 3, published in 1966, details the electronic spectra of polyatomic molecules. And finally, Volume 4, published in 1979 and co-authored with K.P. Huber, outlines the constants of diatomic molecules. This comprehensive work remains a foundational pillar for exploring our chemical universe. In 1971, Gerhard Herzberg achieved the highest honor in science by receiving the Nobel Prize in Chemistry. The award formally recognized his significant contributions to our understanding of the electronic structure and geometry of molecules, particularly free radicals. The Nobel Committee noted that it is quite exceptional for a single individual to lead an entire field of such importance to this extent, comparing the impact of his laboratory to that of legendary institutions like the Cavendish Laboratory and Bohr's Institute. Of course, genius may come with its quirks. In a humorous incident known as the Leningrad train mix-up, a Soviet official mistakenly informed Herzberg on a train that he had won the Nobel Prize in Physics. He spent 6 isolated hours puzzling over this news, only to discover upon arrival that the award was actually for chemistry. Beyond his own research, Herzberg was a builder of intellectual communities, creating a Republic of Science at Canada's National Research Council, NRC. During the golden years, starting in 1948, he directed the NRC's Division of Pure Physics, quickly establishing Ottawa as the global epicenter for molecular spectroscopy. Through his network, he nurtured a vibrant scientific ecosystem, mentoring a remarkable generation of leaders, including future Nobel laureate John C. Polanyi, high-resolution grating spectrometer pioneer Alex Douglas, and Lorne Gray, who later became the president of AECL. Herzberg's guiding principle was intellectual freedom. He strongly protected his researchers from administrative burdens, believing that true and unencumbered intellectual freedom is the ultimate driver of human discovery. As a true philosopher of science, Gerhard Herzberg stood as a fierce defender of intellectual freedom against bureaucratic overreach. When government reports threatened to restrict funding exclusively to predictable, economically driven applied outcomes, Herzberg fought back. He argued passionately that all applied science relies entirely on the unpredictable breakthroughs born from pure, curiosity-driven basic research. Forcing scientists to forecast practical applications, he stated, was historically ignorant. In his own defiant words, bureaucracy is a far greater danger to Canada and to science than the Republic of Science. He often reminded short-sighted politicians of Michael Faraday's famous retort regarding the value of discoveries, "Sir, of what use is a newborn baby?" Beyond the formulas and accolades, who was the man himself? In 1985, Gerhard Herzberg outlined 3 core values essential to a scientific life, defining what it means to be a universal citizen. The first is humanity, This involves the moral obligation to communicate science and to recognize that great discoveries hold the same cultural value as magnificent works of art. Herzberg embodied this principle, finding harmony as an accomplished baritone while singing Schubert Lieder. The second value is humility, the continuous practice of recognizing one's limitations, completely rejecting ideological dogma, and deeply respecting the vastness of the universe and the contributions of past thinkers. Finally, there is humor, maintaining joy, camaraderie, and a light heart in the face of significant scientific and political challenges. Gerhard Herzberg's profound impact on humanity has earned him a well-deserved, cosmic immortality, reflected in both an enduring earthly and celestial legacy. On Earth, his memory is honored through the prestigious Insert Gerhard Herzberg Canada Gold Medal, which awards $1 million annually to support curiosity-driven research. His name is also perpetuated by the Herzberg Institute of Astrophysics and the Herzberg Experimental Hall at the Canadian Light Source. However, his most poetic tribute lies in the heavens. Asteroid 3316 Herzberg now orbits permanently in the main belt of our solar system. This serves as a fitting, eternal monument to the young boy from Hamburg who dreamt of becoming an astronomer but instead dedicated his life to deciphering the very light that stars emit.